Happy Wednesday, Year 5. We're about to go through the answers for today's arithmetic. Hopefully you found it okay. And again, I promise that this video won't be as long as Monday's because I realised at the end that Monday's was 25 minutes long almost. But hopefully it gave you those reminders so that you found the next day's arithmetic a bit easier. But yeah, I'm going to try and not make it as long today. So let's skip on. Right, so the first question was an addition question, and we're looking at a number that is 29.909, add something equals 35. So an option you have is to do 35 subtract 29.09. However, that will include a lot of exchanging because this number has no decimals. So you're better off counting up. Now when we look at this number here, we've got 29 and some decimal places. Now we're trying to get to the number 35, so the decimals that we add will make this number a whole number, which will make it 30. So we need to think about the fact that from 30 up to 35 is 5. So we know the beginning of our answer, and I'm going to write it underneath just so I fit it in the square or the rectangle more. I can't fit it in the square and rectangle, sorry. So we know the answer begins with 5 point something because we're going to work out what the decimal bit is. That's the tricky part, and we're going to work that bit out, but we know that would take us up to 30 and we're trying to get to 35, so we need another 5. So it's thinking about the knowledge that we need, okay, to understand with decimals to help us to work this out. Now, if it was 29.9, we're in the tenths column, okay? So the first column after the decimal we know is a tenths column. Now, the knowledge that we know is that you need 10 tenths to have a whole number, okay? And the clue is in the word tenths. So 10, you need 10 tenths. So you would add to this number to make it whole, to make it 30, you would add 0.1 because the 9 tenths add the 1 tenths would make it whole. If the number was 29.85, we've moved into the hundredths column. And again, the clue is in the word hundredths. We need 100 hundredths to make a whole number. Here, we've got 85. So if I add 5 hundredths to that, it gives me 90 hundredths. And if I add another 10 to that, it gives me 100 hundredths. So I would add, to make this number whole, to make it 30, 0.15. The 85 hundredths add the 15 hundredths would give me 100 hundredths. Okay, now we're looking at 29.909. So we've gone into the thousandths. So I wonder how many thousandths we need to have a whole number. Yep, hopefully you're all sat there rolling your eyes at me going, yes, Ms. PA, we get it. It is 1,000 thousandths. Now, we've got 909. So we're thinking, what do we add to 909 to give us 1,000? Now, we know that 909 isn't very far away. So I'm thinking in my head, if I added 1 to that, I'd have 910 thousandths. Okay? And then I'm thinking from 910 to 1,000 is a difference of 90. So I've added 1, then I've added 90, that takes me to 1,000. Now you can do this on a number line, you know how to do that. I'm showing you that number line in my head. So I've added 1 to make it 910, then I've jumped from 910 to 1,000. Now if on your number line you might want to jump to 950 first and then to 1,000, but I've done it in one jump. So I know I need to add 91 thousandths, okay? So I just need to think about how I write that. So if I'm writing it here, if I choose my pen, if I write 91, okay, so if I write my answer as 5.91, because we know it begins with a 5, actually, if we're going to thousand column, I've written 910 thousandths, so that is completely wrong. So we need to think about a 3-digit number that reads as 91. So we need a 0, and then we need a 9, and then we need a 1, okay? So that is your answer for that one. You may have done a sum at the beginning and got that answer. That's brilliant. However, I think you're more likely to make a mistake because there's no decimal. So you'd have to put 0.000 and then exchange, and it gets a little bit complicated. I think you're much better to work on using your understanding of numbers. Okay, so hopefully that made sense. There'll be a similar question tomorrow that you can apply this knowledge to if you didn't quite understand it when you had a go at it today. Right, again, we're thinking we've got into the thousands. So we'll look at this number, 20, subtract 0.899. Now we know we're taking away less than 1, okay, because a decimal, 0.899, is less than 1, okay? So we know our answer is going to begin with the number 19. Okay, because if we were taking away 1, the answer would be 19. So if we're taking away less than 1, it's definitely going to be 19. All right. Now we're thinking there in the number 20. All right. 20 is the same. 20 is equal to, it's the same as 19 add 1. All right, I hope you agree with that. So the equal sign means balance. So each side of it needs to equal the same. 19 add 1 is a different way of writing 20. All right, so we're thinking about, that's 19, that's part of our answer. We're now thinking about this 1. Now we know, if I look under here, you need 1,000 thousandths to make one whole number. So in that 1, we've got 1,000 thousandths. So we're thinking about the number 1,000, okay, and we're going to take away 899 thousandths there. Okay, so that's that 1,000 thousandths in that number, and we're taking away 899 of them there. So this is the sum that we're actually thinking about. So when we think about it, we can count up, we can find the difference, a bit like with Diffie. Okay, the numbers are quite big numbers. Yes, they're not too far away, but for me it's easier to add 1 to this to make it 900, and then add 100 to it to make it 1,000. So count up from that number. So 899 add 1 is 900, then add the 100 gives us the 1,000. So we know we had to add, to get that answer, 101 thousandths. So that is your answer there. Okay, right, moving on. 325 multiplied by 9. Now if we were in school, I know there would be people, and I'm thinking of Hayden, would have his hand up straight away, and I think Jasper probably would, and they would say to me, Mrs. PA, instead of doing a sum, what I did is 325 multiplied by 10. I'm probably going to be wrong now, and they're both going to send me work that says that they did a different, they solved it in a different way. But when I was setting this question, I thought, what different ways would people use? And I know that they've done this in the past. So they would do 325 multiplied by 10. So we know that that answer is 3,250. Okay, I hope you agree with me about that. Then they would do 325, subtract 325. So they would take away 1 lot of 325, which would give them the 9 lots instead. Okay, if you didn't look at it doing it that way, what I would hope you would have done is write your 325 and multiply it by 9. Now we looked at this last term. I've set it as a bit of a reminder because it's a good skill just to practice. Now you might have given up on this question because you thought, oh hang on a minute, I don't know my 9 times table. However, I would argue very strongly you all know your 5 times table, you're all able to count in 5s, you're all able to count in 2s, and actually your 3 times table is not that difficult. So even if you didn't know it off by heart, or you didn't have that answer at your fingertips, you could work it out. So 9 times 5 is 45. Okay, again, make sure you are carrying to the next column, but that your number reads as 45, not the other way round. Okay, 9 multiplied by 2 or 2 multiplied by 9, it's commutative like addition is, so it doesn't matter which way round you do it, which times table you use, which is 18. So 2 times 9 is 18, add 4. So 18 add 2 is 20, and then another 2 will give you 22. Okay, now with the 9 times table, it's really close to the 10 times table. So if you know 10 times 3 is 30, then 9 times 3 is just 3 less than that, which is 27. So 27 add 2 is 29, and that is your answer. And if you took that away from that, then you would get the same answer. So both ways would have given you the same answer. It just depends how you want to work. Okay, right, moving swiftly on. Right, 3,600 divided by 3. So this means how many lots of 3 can you get out of 3,600? Now hopefully when you looked at this number you thought, hang on, let's think about 36 instead. Let's divide the number by 100 and make it 36. So 36 divided by 3. Again, if you don't know your 3 times table, you do know other times tables that are helpful, like your 10 times table. So 10 times 3 is 30. So there are 10 lots of 3 in 30. So then 30, then it would be 33. So there are 11 lots of 3 in 33. So yeah, there are 12 lots of 3 in 36. Now that is the bit of information you need to solve this question. You can then use it to help you to answer the next part. So I would be thinking about 3, let me see, Yeah, so I would be thinking, where's my pen? There it is. So I'd be thinking, okay, so I know that, so 360 divided by 3. Okay, so I'm thinking the number I'm looking at dividing by 3 is 10 times bigger, so I should have 10 times the amount of 3's. Okay, hopefully you agree with me on that. So therefore, when we look at this question, the number is 10 times bigger again. Okay, so my answer needs to be 10 times bigger again. So the answer you should have had is 1,200. Okay, so it's using something that we know quite easily to help us work out something we're not sure of. Right, let's look at these questions then. So these were the ones on the other side. Okay, so we're looking now, instead of looking at thousands, we've gone back to hundreds. Now again, hopefully you remember you need 100 hundredths to make one whole number. So we're looking at the number 120 and a decimal, so part of another number. We're trying to get to 121. Now hopefully you didn't sit and do a sum because you realised it is just the very next whole number. So we've just got to look at this and say we've got 95 hundredths. We need 100. So what do you add to 95 to make 100? And hopefully you've all got the answer 5. But we have the same issue where if I just wrote 0.5, that actually, if we're going into hundredths, is 0.50. So that would be 50 hundredths. So that is not the right answer. Okay, so you've got to think about it. Actually, we're adding 5 hundredths. So we've got nothing in the units or the ones, nothing in the tenths. Okay, we've got to add 5 hundredths, and that is the hundredths column. Okay, so your answer should be 0.05. Okay, now moving on, we've got a subtraction sum here. The numbers are really far away from each other. Yes, they've both got 49 at the end of them. However, I think the most efficient way is to do a sum. Okay, to do column subtraction. So we're thinking about, do our numbers match the numbers in the question? Yes, they do. Are they lined up correctly? It's handy because they're both the same length. They both go from thousands to units or ones. So actually it's quite straightforward to set out. So we just now need to make sure we calculate correctly. So 9 subtract 9 is 0. 4 subtract 4 is 0. Now this is where we get to the tricky part. We've got 0, we've got nothing. Can we take 2 away from it? No, we can't. So don't just swap it over and put the answer 2, because that would be wrong. So you're going to have to exchange. Okay, we're going to change our 9,000 to 8,000. Okay, and we're going to take the 1,000 that we've borrowed and put it on the hundreds. Okay, now when we talk about this in school, it can become a little bit confusing because what you really want to do is think about this as that's 9 changing to 8 and then 0 becoming 10. Now, what you've got to be clear about is you've borrowed 1,000, and because you've lined everything up correctly, you can now think about this as 10 take away 2. But actually, because it's in the hundreds column, it's 10 lots of 100, which is 1,000. Okay, so we can think about it as 10 subtract 2, but just make sure you're clear about what you're actually exchanging. So 10 subtract 2 is 8. Okay, and then we've got 8 subtract 2, which hopefully you found is 6. Okay, right. Last question for this set. So you've got 10.5 divided by 10. Now our number system is really quite wonderful. When we come to spell in English, we are a bit scuppered really, because when we look at the spelling patterns, there's all these different ones for the same sound, and it becomes really, really complicated. English is one of the most difficult languages to learn in terms of spelling. However, with our number system, it is really straightforward. Each column, if you're going to move to the left, okay, so moving up, each column is worth 10 times more than the column it is next to. So in units or ones, a 10 is worth 10 times more than that. Okay, 100 is worth 10 times more than that. And then if you move down, it's worth 10 times less. So from units to tenths, it's 10 times less. So if we're dividing by 10 or 100 or 1,000, that's why we can just move the numbers up or down, however many columns we need to. Okay, so if we're dividing by 10, we're only going to move the numbers down one column to make each digit worth 10 times less than it was. So I'm looking here at the number 1 digit. It's in the tens column, so it's worth 10. I'm going to make it worth 10 times less than it was, so it's now worth 1. Okay, 1 unit or 1, 1. My 0 has to stay in the same place, so it has to be right next to the 1, between the 1 and the 5. Okay, it's really important because otherwise that number just becomes 15 or 1.5, but actually it's 10.5, so the 0 must stay there. Okay, so the 0 is still worth 0, but it's now in a different, it's holding it's like a placeholder but in a different position. Now the 5 was worth 5/10, so we're going to make that worth 10 times less than it was, and it's now worth 5/100. So your answer is 1.05. Okay, right, so hopefully you did all right with that. Now the last question. Now you had this yesterday, so you may, if you were clever, you may have used your answer from yesterday to help you work this out. However, I think this is quite straightforward when we use our brilliant. My husband was asking me about this and he said, what on earth does that stand for? And I said UDC. So even if you didn't solve it, what I do hope is that you actually did U and D. Okay, the calculate bit is the hardest bit at the end, but actually the U and the D should make it much easier. So out of a class of 24, 10 of the children got 11 right answers during a test. Okay, so I'm going to underline anything that is important. There's 24 children, 10 of them got 11 right. Okay, and then the other 14 got 9 right. So there's 14 children that got 9 right. Okay, now the test had 15 questions, and I'm going to underline all of that just to be really clear. How many answers did the class get wrong? Okay, so I'm now going to do the D part, which is the draw. So I am going to think about, I've got a class of 24 children, but actually that's not so important anymore because they've split it up into 10 and 14, so I'm not going to worry about that at the moment. So I've got 10 children, and I'm going to draw my lovely children again. The most beautiful drawing you've ever seen, and I'm not going to draw 10 of them, but I'm just going to show that I've got different children. There's 10 children. Now if they got 11 right and there was 15 questions, they each got 4 wrong. Hopefully you agree with me about that. So that group of 10 children got 4 questions wrong, so altogether that group got 40 wrong. Okay, now I've got 14 children this time, all right, and I'm not really going to draw the pictures of them again, though, just being clear about that. This time this group got 9 right, so out of 15 each child would have got 6 wrong. Okay, I hope you follow that. So they got 9 right, but there was 15 questions, so they got 6 wrong. So we now need to look at 14 multiplied by 6. Now what you could do is think about 10 times 6 is 60, and then add 4 times 6, which is 24. Okay, so I've broken up that 14 and times each part of it by 6. So that gives you 84. Now if you can't do that, you can obviously go to doing what we looked at in a previous question, which is 14 multiplied by 6. So 4 times 6 is 24. Okay, and I hope my mouse clicking is not annoying you, so I apologise. And then 1 times 6 is 6, add 2, which is 84. Now if you look, we've got exactly the same answer. Now that's how much each group got right, got wrong, apologies. So now all we need to do is to add those two together. So 40 and 80, so 8 add 4 is 12, so 40 add 80 must be 120, and then add the 4 is 124, so that is your answer there. Okay, so I've been looking at these questions and thinking actually they are quite tricky, the questions I've set for arithmetic. However, I know that when we're in school, you get so much from listening to each other. So I'm going to get some feedback from you this week, and I will make it slightly less challenging if I feel that we need to. However, hopefully what you're getting a lot from these videos is some reminders, and if you just remain confident, I know that you can do it. I'm not expecting you to get everything right, I'm not expecting you to finish every question, but I want you to not lose that willingness to have a go, because when you start something and you try it, you generally find that you can do it. Okay, you can do brilliant things, remember that, year 5. Okay, so I will speak to you on Dojo a little bit later.